Hey guys, so yesterday we looked at the different types of ray diagrams that we can use for convex lenses. Today we'll look at how do I do the same for a concave lens. Okay, so this is again similar to what we saw last time for a convex mirror in the reflection chapter. Okay, so I'm just going to head it as concave mirror lens. Okay, now let me remind you, if the audio is not clear, please raise your volume or use a speaker or please earphones. Okay, you can use any of these and just make sure your volume is high. Alright, excellent. So in a concave lens, there is only one case. No matter where you put your object, the image will always be formed in the same place, in the same manner. Okay. I will make one and I will also give you another one to try out on your own. So let's assume that this is a concave lens and F C F C. Okay. I'll assume my object is somewhere here. Okay, I'll assume my object is between F and C. Now, what rules can I use for this? Okay, the first rule I'll use is parallel. For a concave lens, when a ray goes parallel, it will diverge. Right? This much we know. Diverge in a way that it appears to go through F. Like that. Okay? Now, what about the second rule? Second rule is the optic center rule, right? It is the same one over here. It just goes through the O and keeps going without any deviation. Now, if you see, these two rays have met somewhere, right? Over here. So what I can do over here, I will draw this small arrow. Okay. Now it's very simple to tell the nature of this image, right? First I'll say image between F and O, because it's between the focus and the optic center. What about the size of the image, right? It's small, right? Smaller than the object, so I say it is diminished. And what about its nature? It is inverted. It's not inverted, sorry. What do you call that? Upright or erect. Right? Means it is the same as the image. It's not reversed. And it is also virtual because it's formed on the same side as the object. Okay, so it is a diminished image, erect, and it is virtual. Meaning, if I try to capture it on a screen, I won't be able to do that. Okay, this is the only case that we can find for concave lens. What I want you to try on your own is I'll give you a different object position. I want you to change the object from here to here beyond C. Try out the same type of diagram. See if you get the image between F and O. If you don't, you have done something wrong. Alright. So I just sketch out the diagram for you to note down. You need to complete the ray diagram in this class here itself. Okay. Alright, so I said object should be over here beyond C. Finish this ray diagram, use the same rules, see whether or not you get the image here in between with the same properties. Alright. Excellent. So this is a very small simple thing for concave lenses. Now concave lenses are also used in a lot of places. Simplest thing is in our glasses, the ones we wear, right? For different type of sight, yeah, different type of lenses. We'll learn more about that in the coming chapter. So now what I want to ask you is, sometimes you get cases like this where you can directly have parallel and through the focus and all of that. But what if you're asked to do without any of these rules? Then what? Okay, for example, say that I have a case where assume there's a convex lens okay. Now what if someone gives me a ray of light saying say there's a light going like this, okay, how will it reflect, where will it go? Okay, see, it is not parallel that I can say it will go through F, right? So where will it, how will I finish this ray diagram? Okay, it is simple enough, not very difficult. Okay, so for a case like this, what you're supposed to do, first we'll take a normal. Okay, we know that for convex lens, the image will be formed on the other side, right? So I'll look at this focus over here and I'll draw something like a normal, just like a straight dotted line through focus. Then what you do, take a line that is parallel to this ray but going through this optic center. Okay, so I'll just erase this writing here. It has to be parallel to this ray, but we know that when it goes through optic center, it doesn't deviate, it will just go straight, right? Now if you see, this normal and this parallel line have met at some point. So this point is where I need to pass this reflected ray or refracted ray. Okay, that is how I know which direction exactly to take. Cool. It is the same way you can do it even for a concave lens. Okay, so I'll give you another example of the same topic with a concave lens. Okay, but remember this one. First, you draw the normal to the focus where image should be. Alright, for convex, other side, for concave, same side. Then line parallel to the incident plane. Okay, and finally, this is not a ray, so there is no need to draw the arrows over here. It's just a line. Okay, and finally, wherever this line meets the normal of focus, you make sure the ray goes through there. Right? So let's try to look at it for a concave lens like this. F, C, F and C. Don't worry much about the numbering and all that. Okay. Say this is the incident. Now I need to complete this diagram. How do I do it? Okay. Now if I see this is not going to pass through the focus, so I can't say it is going to become parallel. That's not the case over here. So what can be the case? Again, we'll have a similar rule. What I'll do first, I know for a concave, the image will be on the same side as the light is coming on the object. So first, I draw this normal over here. It'll have to be this long. Okay. Then, like I said, this parallel to this line, another line that goes through O, like this. Okay, make sure it's parallel with the scale. Okay, now this line is parallel. If I see it is cutting at this point over here, so what I will do, I will get a dotted line from here and I'll say that in the same direction the light will go away. Okay, do you see? Because for a convex lens we notice that the light comes towards the axis, but for a concave light tends to go away and then you trace it back. Okay, so these are two different type of diagrams that can be asked as a question. Okay, they'll give you like the blank diagram with just the ray. Okay, and they'll ask you to finish off the diagram, in which again follow the same step. If it's convex, this the parallel line and just extend it to meet it. For this it will be on the other side, so you need to extend back to meet. Okay, steps are pretty much the same. Okay, so for you to practice, I'll give you one diagram which I want you to do in your notes right now. Okay, I'll give you a convex one. There is a convex, right? F, C, F, C, 1, 2, 2, like this. Cool. Alright. This is a diagram given to you, so follow the same steps. Okay. Parallel to this, then deviate, meet it at the normal over here. Cool. Okay, so that's it for today. Tomorrow we'll look at certain numericals and sums and stuff that we can do with these lenses. Okay, again you'll find it very similar to the mirrors chapter, so should be easy enough. Alright, that's it for today. Thank you all. See you in the next class.